Okay, so now we're going to look at problem number 27, which is a little touchy, but I think we can handle this one, no problem. All right, so basically when we look at the timeline, what we're trying to do here is we're trying to figure out how much the bank will give us in terms of a loan, okay? So this owner is saying that for the next 3 years, 1, 2, 3, that she can make a payment of $2,900 a month. And then in year 4 and 5, she can make a $5,800 payment, which is basically doubling the payment. I made my timeline a little bit long. So we're basically looking at over a 6-year period how much will the bank allow her to borrow. So what we're going to do is we're going to take this $5,800 and we're going to act like she made it for the full 6 years, and then we're going to adjust it for this $2,900, which is what the bank is going to have to adjust for when they do their calculation. Okay, so what we're going to be doing is we're going to be looking at the present value of an annuity over a 5-year period, which is 60 months, and we're going to adjust it out for a present value of, whoops, I got a bad focus. All right, let me bring the camera back in focus. Camera's on autofocus. There we go. All right, present value of annuity over 36 months. Okay, so here's my $5,800 that we're going to normalize over the whole 5 years. And what we're going to do is we're going to say 1 plus the interest rate in this problem is 0.0975. So we're going to say 0.0975 divided by 12. And because we're doing this for 60 payments, then we're also going to do the 0.0975 divided by 12 on the bottom. Then we're going to adjust out $2,900 of the payment for those first 3 years, which is 36. And we're basically going to apply the same math strategy, only raised to the 36th. Now, in solving this problem, what's repeating? What's repeating is 0.0975 divided by 12. So let's go ahead and determine what that is now so that we don't have to keep rewriting that. And that's 0.008125. All right. So let's do this. 5,800 times 1 minus 1 over 1.008125 raised to the 60th divided by 0.008125 minus 2,900, 1 minus 1 over 1.008125. Here we're just raising it to the 36th divided by 8125. All right, so when we work this through, we're going to take, let's look at this first half first. 1, we're going to start right here. 1 divided by parenthesis 1.008125, y to the x, 60, y to the x, parenthesis, equals, and that's going to give us 5,800 times 1 minus 0.615371 divided by 0.008125. And then when we do this all the way through, 1 minus 0.615371 equals, divided by 0.008125 times 5,800, we get for this first part, $274,565.9323. But we still have to subtract out that $2,900. So then we're going to do the same thing we did on the other side. All right. We're going to take 1 divided by parenthesis 1.008125 y to the x, 36 y to the x, parenthesis equals 1 minus 0.747278 divided by 0.008125. Okay. And then let's go ahead and work this all through. 1 minus 0.747278 divided by 0.008125 times 2,900, we get 90,202.31385. And when we subtract those two, we get the final answer of $184,363.6185, which would round to $184,363. Push this up a little bit so you can see the final answer. 0.62. So what we did, this part of the problem equals 274,565.9323, and this part of the problem equals 90,202.31385, which we're going to subtract, which gives us the final answer. And this problem covers number 27 and 28. All right, so now we're going to move on to question number 29.